Hello, my fellow Java code geeks. Today we're going to be talking about Java interview questions and the answers that go with them. Now, as someone who has interviewed many people, I've certainly asked my share of these questions. We're going to go through the 10 most common questions that I've asked on interviews. Now, complementary to this video tutorial, you can find related articles and resources in the description below. Of course, you may visit Java Code Geeks and stay up to date with everything Java related. Just before we continue, if you guys like these guides and videos, take a minute to subscribe, like, and don't forget to hit that notification bell, just so you know when our next video is up. So, without further ado, let's get started. Question number 1. Why is Java platform independent? We're going to consider a scenario where you're writing a speech and you have to deliver it in different countries around the world. So what happens is, of course, you write the speech in English because we understand English. In America, when you deliver the speech, they all understand it. The only trouble is, when you go to France, they're not going to understand it. They speak French. So what do you have to do? You have to write a second copy of the speech in French and then deliver it. Of course, then if you go to Spain, they won't understand either one. So you have to write a third copy in Spanish. And you can see that this is quickly going to start becoming impossible for you to do because there's so many different countries and so many different languages. But imagine for a minute that each country built its own translation studio. Now the speech is still written in English, but instead of you going to the country and delivering the speech in front of thousands of people in English, what you're going to do is you're going to go into that country's translation studio. Inside is going to be a translator. That translator is going to speak the language of the country wherever the studio happens to be. Now you're going to read your speech to the translator. And the translator, let's say the studio is in America. The translator will just repeat your speech to thousands of people in English. Of course, they can all understand it. But if you're in a translation studio in France, the translator is going to read your speech in French. He's going to translate it. And they can all understand it. And of course, if you're in Spain, same deal. The translator inside that translation studio will speak Spanish. And he'll read the speech in Spanish, and everyone will understand it. Now, Java works the same way. When you write a program in Java, you could write it on a whole bunch of different kinds of computers. Mac, Windows, whatever. And inside each of those computers is something called a JVM, or a Java Virtual Machine. So what happens is, the Java Virtual Machine will be running on Windows. There could be a Java Virtual Machine running on a Linux operating system, and of course maybe on a Mac OS, just to name 3 examples. So what happens is you write a Java program, and that Java program doesn't run directly on Windows. What happens is it goes to the Java Virtual Machine, and it runs there. Okay, and then of course there's a translator in there, and that translator will take your program and make the compatibility changes to allow it to run on Windows, on Linux, or on Mac OS, depending upon where the Java Virtual Machine is sitting. If you're running a Linux system, the Java Virtual Machine will translate any Java code into code that will be running on Linux, and that computer will then be able to run the program. Explain the difference between instance variables and local variables. So let's start with local variables first. X here is inside of a method, and this is a local variable. In other words, the scope of X is only available inside method number 1. So inside method number 1, I can use the variable X however I like, but any code outside of method 1 can't see the value of X. It can't even see the variable X. So for example, if I write a second method and I try and set X equal to 3 or use X in any way, this will generate an error. It'll generate a compile error because this method does not recognize that the variable X has been declared. However, if I write a third method, I can declare another local variable, same name X, doesn't matter that it's the same name, this will be treated totally separate from the original X in method number 1. It's similar to having 2 families, both with a child named Mike. Just because they're both named Mike doesn't mean they're the same person. Instance variables, however, are a little different. Here we have a variable y declared at the class level. It's not being declared inside of any method. This variable is called an instance variable because any of the methods on this class have access to y, and it's only one copy. Therefore, if method number 1 sets y to, say, 2, it's 2 for every single method on this class. If method number 2 then goes and changes y's value from 2 to 10, it'll be 10 for every method on the class. Each instance of the class can have its own value for the variable y. So if we instantiate an object of this class, we can set y equal to 4. If we instantiate another object of this class, we can set y equal to 7. Those are two separate instances. Therefore, each instance has its own value of y, and the methods that run within it will use that value of y. So let's look at an example that shows the difference between local and instance variables. So here, as you can see, I have a class called interview questions. That'll go along with this video. I have the main method just instantiates a copy of that class, and we call start. So this is where our main program is going to be. So the first thing I want to do is I want to write a method. We'll call it method 1, no parameters. And all we're going to do is I'm going to say int x equal 5. That's it. Now, if I try and print x, right, and I run this program, let me call method number 1. If I run this program, what's going to happen is it's going to call this method, it'll set x to 5, and then it'll print x. So let's run this. You'll see an output of 5. There we go. Perfect. Okay. Now, what happens out here in start if I, instead of printing x here, let's say I try and print x here. Notice this is underlined in red. It's telling me that it can't find the symbol x. In other words, the variable has not been declared, but it was declared here. But the scope of this variable is local, meaning it only exists inside this method. As soon as the method exits, this variable is no more. It's destroyed. So not only is there no value, there's no variable either. Now let's say I want to declare another method. Let me copy this method here. Now I'm going to have method 2. And in method 2, I'm going to declare another variable x. We're going to make it 7. Okay? And then, of course, we know we can't print x here. But what we're going to do is we're going to call method 2 over here. And inside each of these methods, we're going to print x. Okay? So now we're going to call method 1 followed by method 2. And let's run this. And as you can see, we get 5 and 7. Notice this value of x does not affect this value of x. They're completely separate. They're local to their methods. This variable only exists in here. This variable only exists in here. Now let's look at an example of an instance variable. So again, I'm here in my interview questions. I have cleared out all the old code, and I've also created a new class called rectangle. It has instance variables length and width. Notice these variables are not declared inside of any method. They're instance variables. They're out here at the top of the class. And I have my constructor where I can initialize my length and my width. So the first thing we're going to do is we're going to declare a variable of type rectangle. And we're going to call it R1. And that's going to be equal to a new rectangle. And we'll pass in 10 by 20. Okay? So that's going to be the dimensions of our rectangle. So what we're going to want to do is we're going to want to print the dimensions of the rectangle. So let's say r1.print area. We'll just say area. Now let's go and write this method. So we'll go into our rectangle and we're going to write a method, public void. It's going to be called print area. And the only thing it's going to do is it's going to print the dimensions. So let's say length by width, colon, area is, and then what's the area going to be? It's going to be length times width. Okay? So what we're going to do now is run our program, and we should see 10 by 20, area is 200. That's perfect. Okay? Now you notice that these variables are not declared inside this method. This method has access to all of the instance variables. Each instance of rectangle can have a different value for these variables. So for example, if I create another class of another object of type rectangle, let's do that here. Here we have another rectangle. The dimensions are 15 by 15. It's actually a square. We're going to print the area. Let's run this. And we get exactly what we would expect. Now notice that when we set the dimensions of rectangle 2, that doesn't change anything about rectangle 1. Rectangle 1's area is still, well, it's 10 by 20, and it's still 200 area. Nothing changes in rectangle 1. Each rectangle, each instance of rectangle, has its own values. Now what happens if we change one of the values? So let's go back to rectangle, and we're going to write a method that allows us to change the dimensions. So we'll say public void, we'll say change dimensions. And what we're going to do is we're going to pass in a new L and a new length and a new width. And all we're going to do is we're going to set the length equal to L, and we're going to set the width equal to W. So if we change our dimensions, well, what should happen is these variables will change, and this method that uses the variables will see those changes the next time it's called. So let's try that. Let's say R1.change dimensions, and instead of 10 by 20, we're going to make it 5 by 7. Okay, and then we're going to print the area of rectangle 1 again. And we should also print the area of rectangle 2 again. So let's run this and see what happens. As you can see, we start rectangle 1, 10 by 20, area is 200, that's up here. Now we print rectangle 2, 15 by 15, that's here, that's 225. Now we change the dimensions of rectangle 1 to 5 by 7, and we print the area. Notice rectangle 1 now has new dimensions and a new area because we've changed them. Rectangle 2 has not had any changes made because that's a separate instance of rectangle, and it has its own variables and values. Explain the difference between dot equals and the operator equal equals. Well, equal equals is used to compare two primitives. If we have two variables and they're both integers, we can see if the values are the same using equal equals. Same thing with doubles, same thing with booleans, and so on. Strings, it gets a little more complicated. Sometimes equal equals works, and sometimes it doesn't. Here's an example where it works. If we declare string x and string y, they both have the same value. Therefore, if we use equal equals, it's going to work. It'll say true in this case, false if they're not the same value. However, we can also declare strings as follows. New string, and then pass in the value, the initialization value. This is the way we create and instantiate more complex classes that we've been writing all along. Now, if we create our strings this way, equal equals is not going to work. And the problem is that A and B refer to the memory address where the value hello is stored. It's a little bit different than the above example with the green check mark. Because A and B refer to the memory address, they're different variables and they have different memory addresses, which means equal equals returns false because the addresses are false, are not the same. Therefore, whenever you're comparing strings, just to be safe, we always use the dot equals method instead of the equal equal operator. And here is an example of how we would do it. If A dot equals, so we're calling the dot equals method on string A, and we're passing in string B. Java will then compare the values of both of those strings and return true if they're the same, false if they're not. Let's look at an example in NetBeans. So first we're going to declare two variables. Now those are primitives, and I'm going to check if x equals y, then we're going to print, equal. Else we will print not equal. All right, let's just run this real quick, make sure this is working. This should print not equal, and it does. If we change this value to 4, of course, when we run this, it should print equal, and that's perfect, okay? Now let's use strings. So let's say string x equals Joe, and we'll do the same thing for y. All right, now these are obviously not the same, so when we run this, we should get not equal. If we change Harry to Joe, now what we're going to do is we get equals, and that's perfect. However, if we declare our strings a little differently, let's declare it using the object instantiation method, which is new string. We'll pass in Joe, and then we're going to do the same thing for y. Now let's run. Notice we get not equals, even though the values are the same, and that's because, once again, x is a memory address pointing to where the value of Joe is stored. Y is a memory address pointing to the value of this Joe. Where is that stored? Because they're two different variables, they're pointing to two different locations in the computer's memory. The memory address for X is not the same as the memory address for Y. They're two separate variables. Therefore, when we compare them, Java says, well, they're not equal. They're different memory addresses. It's not looking at the actual value. If we want to look at the actual value, we have to say x.equals, calling the method on the string class. We're going to pass in the string we want to compare it to. When we do that, you'll see that we actually get the value that we expect. How is the final keyword used with variables, methods, and classes? With variables, it prevents the value from being modified. Yes, you can initialize the variable, but once it's been initialized, you can't change it anymore. So as an example, let's say you create a variable called pi. If you set that variable equal to 3.14159 and so on, what happens if someone tries to come along and change pi? The rest of your program won't work. So you can mark that variable final so nobody can then later on change that value, multiply it by 2, whatever, do something that accidental and make the program not work. When using the final keyword with a method, it prevents the method from being overridden. Let's say in a company you write this really intense method that does a lot of financial processing and you don't want any child classes to override it because you want that method to always work the way the company wants it to work. In that case, you would mark the method as final. You can inherit from the parent class, you can use the method, but you can't override the method and change its functionality. When using the final keyword with a class, you prevent the class from being inherited. Again, this is more of a security thing or a preference thing with a company. If you have a series of classes that you don't want anyone to inherit because you want them to be used just as is, no modifications, no inheritance, you mark the class as final and then no one can inherit it. So let's look at an example of the final keyword in NetBeans. So again, I have my interview questions class. I did modify my rectangle class slightly. I added a default constructor. So if you instantiate a rectangle with no parameters, the length and the width would just be 0. Everything else is the same. So now let's take a look at what would happen if I marked length and width as final. So what would happen here is you notice we have compile errors. We don't have compile errors here because this is the constructor. We're initializing our variables. This is the first time they're going to be set. However, once they're set, we can't go ahead and change them in another method because that violates the keyword final. And as you can see, if I hover over it, it says we cannot assign a value to a final variable. So we're going to take that out. Now let's take a look at what would happen if we create a new class called square. Now we have this class square. We're not going to really put much code in here. All I want to do is I want to show you what would happen if we try and override our area method. So in rectangle, as you can see, we have print area and we're printing all this stuff. Well, let's say with a square, we're going to do print area. We're going to override it. And then what we're going to do is we're going to print area of our square is 7. Well, obviously that's not correct because it really should be using length and width, but we're going to change what's printed. Okay, so let's run this. Well, before we run it, let's go here and let's create a variable square s equals new square. Okay, there's our default constructor. And now let's change the dimensions. Remember, when we inherit from square, we get all these methods for free. So let's change the dimensions to 4 by 6. And now let's print the area. Now remember, we overrode this method. So when we run this, it's going to print area is 7, which is not correct. And that's a reason why we don't want someone to override that method, because that method is correct and there should be no changes to it, whether you're doing a rectangle or a square. So in the rectangle class, if we mark this method here, print area, as final, then no one will be allowed to override it. As you can see here, we now get an error message at compile time that says we can't override print area because it was marked as final. Let's undo that now. And let's take out our overridden method. Okay. Lastly, let's take a look at rectangle, the declaration. If we mark the class as final, that means no one is allowed to inherit from it. Well, square is inheriting from it, and now all of a sudden we get this error. We can't inherit from a final rectangle. In other words, rectangle class is not allowed to be inherited from. So we have to either not do it or remove the word final. And then we're good to go. What is the difference between pass by value and pass by reference? And when does Java use each? Pass by value is when you have a method and the parameter is a separate copy of the passed-in variable. In other words, you don't use the variable that was passed in as a variable, you actually create a new version of that variable inside of the method, which means modifying it will not change the original variable. Pass by reference, however, is using a pointer to the variable. There's one variable stored in memory, and when you pass by reference, you're passing in a pointer to where that variable is stored. So if you change the actual value, there's only one variable being stored in memory, and we're just pointing to it, so it will modify the original variable. Let's take a look at an example of how all this works. So here's some code, and it's going to demonstrate pass by value. The first line of code creates a variable called x. So we have this x, it's pointing to a location in the memory of the computer, and we're going to fill that memory location with a value of 3. Then we call this add1 method, and we're going to pass in the value of x. So we go down to this method, and you notice this method's parameter is called n. So we're going to create a new copy of the variable. We're going to create a new variable called n. It's going to point at some memory location different than x, and that's going to be filled with the value of 3, because that's what came into the method. We then go to this line where we increase n by 1. So n will change from 3 to 4. Notice x is not changed because n is a separate copy of the variable. When we return, we go back to the print statement and we're printing x. In this case, we're going to print 3. X is not changed. Here's an example where we use pass by reference. Pass by reference is done when we're passing custom classes. Classes that we create, not primitive variables and not strings. So let's take a look at the right side of the screen. We have this class called child. There's an instance variable age. Now I didn't write the constructor here because it would have been too messy on the screen, but basically the constructor is pass in the age and I will set the instance variable age to whatever you pass in. We also have a couple of methods, give me the age and increase the age. Now let's look at the left side. The first thing we do is we create a variable c and we instantiate a new child passing in a value of 3. So what happens there? We have to create the child in memory, a child object in memory. We create a variable called c, and that variable is going to point at the memory location where the child object is living. When we pass in 3 into the constructor, it changes the age to 3. If there are other variables, there will be a whole bunch of other variables in there as well. Now let's go to the next line of code, have birthday. We pass in our object c, and we're going to call the method have birthday. Now you notice have birthday has a parameter and the variable name is n. So unlike before, we're not going to create a new variable, a new memory location, and a new child object with the variable n. All we're going to do is we're going to create a variable n and point at the exact same object in memory that we had before. There's one object, both variables are pointing towards it. Now we go inside the method and we call increase age on variable n. Well, which child object are we referring to? Are we referring to the one that was pointed to by c? Or are we referring to the one that was pointed to by n? The answer is that doesn't make sense. There's one object in memory. They're both pointing at the same thing. So when we call increase age, we add 1 to age. Age will change from 3 to 4. And then when we return and return again, we now go to the print line. And when we do the print line, we call c.getAge. Well, c is pointing at the same object that n was pointing at. Of course, n doesn't exist anymore because it was a local variable, but they're both pointing at the same child object, and that child object was changed inside the method haveBirthday. So when we call getAge, that will return the age of this child object, which is 4, and that's what we'll print. So let's take a look in NetBeans and see an example of how all this works. We still have our rectangle class, and we have a method change dimension, and that's fine. And then what we're going to do is we're going to create a new rectangle, and we're going to pass in, say, 10 by 50. Those are going to be the dimensions. Now let's create another method here, And in this method, we're going to say x.change dimensions, and we're going to tell it it's going to be 30 by 40. And then over here, we're going to call change something. We're going to pass in R1, and we're going to print the area each time. I don't need to do that. I just have to say print area. R1.print area. All right. So what's happening is we're passing in the rectangle into this method. This method is modifying the rectangle somehow. And because this is a pass by reference, because we're using a custom class rectangle, when we print here, it should actually modify the dimensions of the rectangle. Let's go and check it out. As you can see, it does in fact modify the dimensions of the rectangle. However, if we were to change this a little bit, and instead of R1 being a rectangle, let's say R1 was an integer. And obviously it can't be new rectangle. We're just going to say R1 equals 6. Okay? And we can't say print area. We're just going to say print R1. So that will print 6. And then change something. We're not passing in a rectangle. We are now passing in an integer. And we're going to say x equal 8. And then we'll print R1 here as well. Okay. So now we're doing the exact same thing as what we did with the rectangle. The only difference is we're using an integer. So let's just look at the code again. We have an integer R1. We're setting it to 6. We're printing it. Then we're calling change something, which passes in the value of R1 into a variable called x, and then we're changing x. We're changing the value to 8. Then when we return, we're printing the value of R1 again. Now because this is an integer, it's a primitive, this will be passed by value. So this x is its own separate copy of the variable. When we change it, we're changing x, not R1. So when we run this, we should see 6 and 6. Explain polymorphism with an example. Polymorphism is made up of two key words, poly and morph. Poly means multiple, and morph means to change. So polymorphism, when we're dealing with object-oriented programming, is really a variable taking on many different forms or types. The best way to explain this is to use an example. And we're going to use an example of a zoo. All right, so here we are back in NetBeans. We have our driver class interview questions. We're going to create a zoo here. So we're going to use inheritance. So what I did is I created a class called animal. That class has a name as an instance variable. The default constructor sets it to unknown. We can set the name using this method. And then we have a method here, talk, which just prints, I can't talk because I'm not a real animal. Because animal isn't like a real animal. It's just like the blueprint for an animal. We have to have a real animal like bird or monkey or lion. That's what's going to be able to talk. Speaking of which, I created a child class, bird, which extends animal, and all it does is overrides the method talk. So it's going to say what a bird normally says. Same thing with monkey, ooh-ee, and same thing with lion, roar, right? Okay, so let's go back to interview questions. This is where we're going to create our zoo. Let's say we want to have 2 birds, we want to have 1 monkey, and we want to have 1 lion. So what we would do is we would create an array of birds. So let's say birds, bird array, birds equal new bird. And let's say we have 2 birds. So we have 2 birds, and then we want to create a monkey. We'll go with 3 monkeys. We'll go with 2 lions. Okay. So now what we're going to do is we want to instantiate each one of those things. Create all of the animals. So let's actually do that right now. So let's say birds of 0. That'll be equal to a new bird. And then we'll set the name. Set name, and the name will be Tweety. Tweety bird. Okay. Let's do another one. Birds 1. And this bird will be called Foghorn Leghorn. All right, we'll use the old Bugs Bunny characters. So he was a bird, he was a chicken, right? Okay, so there are our 2 birds. Now let's create the monkeys. So let's change this to monkeys. And we're going to set the name to, who is a monkey? Curious George. Let's see, who else is a monkey? Create 2 more. Let's see, we have 3 of them. Well, you know what? It really doesn't matter. We'll go with Harry and Carol. Actually, maybe for the monkeys, we should use the beginning letter as M so we don't get confused. Michelle. Okay, now for lion, how many do we have? We have 2 lions. So let's create 2 lions. We'll change this to lions. And we'll set the name. Who's a good lion name? Simba. Who else? I don't know any other lions. So I guess we'll just call them Larry the lion. There we go. Okay. So if we want to... we have to change this to 1. Okay, so if we want to print every animal in our zoo, we're going to have 3 loops. Loop through all the birds, loop through all the monkeys, and loop through all the lions. So we would have to do something like this. Let's say we just want to have everybody talk. This is only going to let the birds talk. We have to have a separate loop for the monkeys and a separate loop for the lions. Well, it's a pain, right? We don't really like to do that. So what we're going to do instead is we're going to use a concept called polymorphism. All right, instead of having 3 separate arrays, we're going to have an array of animals. And we're going to have 7 animals. We're not going to have these arrays anymore. Because each of these classes, birds, monkeys, lions, each of these inherits from animals. We can technically put a bird into a variable of type animal. So what we're going to do here is we're going to say bird 0 is new bird. I'm sorry, animal 0. Animal 0 is going to be equal to a new bird. And then we're going to set the name. We're going to do the same thing for all of this. We're going to change all of these to animals. Of course, we have to change the indices. So now we have all of this in one big array, which is nice because we can loop through this array. And now when we run this, you can see that each of these are talking on their own. The first 2 are the birds, the next 3 are the monkeys, and the next 2 are the lions. But you notice in the class animal, talk prints I can't talk because I'm not a real animal. Well, we're not putting a type animal into that array. We're putting type bird, type monkey, and type lion. That's called polymorphism because this variable, this array, can take on many different kinds of values. It could be a bird, it could be a monkey, or it could be a lion. What is the difference between overloading and overriding a method? Overloading a method is when you create a method with the same name as another. The difference is that the new method has to have a different signature. In other words, either the parameter list has to be different or the return type has to be different. So let's take a look at a class called greetings. We have a method say hello, and we're not passing anything in, we're just going to say hello. However, sometimes we may know the person's name. In that case, we're going to pass it in, and then we want to address them directly. Hello, Michael. So take a look at this code. When we run the second line, g.sayHello, it notices that we're calling sayHello with no parameters. So Java is going to look for a method named sayHello with no parameters, and it finds the one in blue, and it prints hello. However, when we call the second version, this time Java is going to look for a method called sayHello, but it's also going to look for one that has a parameter of type string, because that's what we're passing in here. And it finds the second version of the method at the bottom. And this time it will print hello, Jessica. Overriding a method is when we use inheritance. We have a parent class that has a method and a child class that has the exact same method, same name, same signature. That's important. When you're overriding, you have to have the same exact signature, both parameters and return type. So let's look at another example with greetings. We have a method say hello. It will just print hello. But now we're going to create another class, a child class, that's going to extend from greetings, and that's going to be called Spanish greetings. Now we're not going to write any code in here just yet, so when we run this code here in green, when we get to the line that says g.sayHello, we're calling the parent class's method. Well, that makes sense. When we get to the next line, sg.sayHello, well, don't forget, when you extend a class, you get all of its methods for free. So we find sayHello in the parent class, and we run that as well. So both of these will print hello. However, in Spanish greetings, we want to print in Spanish. So what we're going to do is we're going to override the say hello method. In other words, we're going to create another method with the exact same signature and the same name called say hello. This time we're going to print hola. So when we get to the line of code sg.sayhello, Java is not going to look in the parent, it's going to look in the actual object that it was created, which is Spanish greetings. And it's going to find an overridden method, say hello, it'll use that one before it looks in the parent class. So this will print hola. So let's take a look at the example that we used before. We have our zoo, we have our array of animals, we were using polymorphism, and when we run this, you notice that we're getting the talk method called for each specific animal. Now, what happened here? Well, we created animal, and that has a talk method, so it should be printing technically this, but remember, on the bird class, we overrode that method. So it prints chirp chirp. On the lion class, we overrode that method, it prints roar. And on the monkey class, we also overrode that method. But what happens if on the lion class, for example, we don't override this method? Let me comment it out. So now what's going to happen is when we run through this array, here, when we run through this array, what happens is when we call talk on the bird, we're going to find the overridden method and it's going to say chirp chirp. When we call talk on the monkey, it's going to find the overridden method and it's going to say ooh ee. When we call the talk method on the lion, however, it's not going to find anything because we commented out, and it's going to revert back to the parent class's method, I can't talk because I'm not a real animal. Let's double check, make sure that all works, and there it is. Birds, monkeys, lions can't talk. What is a Java servlet? Well, a servlet is used when we're dealing with the internet. So we have your computer, and then websites are stored on web servers. So when you go to an actual website, you're making a request for HTML files. The web server is what has those HTML files. So here's an example, a very simple one, that just has the word hello. The tags, those things are called tags. The B and the slash B are tags that just say everything between them should be printed in bold. So what happens when you go to this website? You say, give me this HTML file that I'm asking for. The web server goes, okay, here you go. And then your computer takes that HTML file, your internet browser knows how to read an HTML file, and it prints the word hello. As you can see, it's in bold. However, what happens if there's a customer database that you want, and you want to go to a website that's going to print a list of all the customers? Well, HTML cannot talk to a database. So when you make this request, what happens is there's a servlet that's in between the web server and the customer database. You write the servlet. So when you make this request, the web server says, Mr. Servlet, I got this request. Can you take care of it, please? So the servlet then queries the customer database. The database replies with all of its information. The servlet then changes that reply into HTML, which can be displayed, tells it to the web server, who then responds to your computer and goes, okay, well, here's the HTML that you needed. Your computer then displays this nice, pretty customer list. Explain Jdbc and give an example. Jdbc stands for Java Database Connectivity. It's basically code that allows you to connect to, query, and do anything you want with a database. API stands for a programming interface. Now, the four main things that you usually do when you're connecting to and using a database is, first, you connect to the database, then you query the database, then you get the results, and then you close the connection. Now, of course, there are other things as well. You can update things, but we're just going to go with these four for now. So connecting to the database, you declare a variable of type connection. There are going to be imports. I'll show them at the end. And then that variable is going to be set to a driver manager class .getConnectionMyDatabase. What this does is this gets the connection and opens up a connection to the database. The database would have to be running on either your computer, or if this code is on a web server, it would have to be running on the web server. After you connect to the database, now we're going to query the database. So first we create a string, query. You can call it whatever you like, but in this string, you're going to put your SQL statement, SQL statement. And then we're going to create a statement variable. and then we're going to create a result set. We're going to execute the query, and we're going to get a result set, which leads us into step 3, getting the results. We're going to do a while loop, and the result set class has a method called next, which basically means go to the next row of the result. We can get string. The variable that we're passing in is name. That's the column header for the database that we're querying. And then, of course, we have to close the connection. Now, all of this could result in an error. Maybe the database can't be opened. Maybe something happened. Maybe it went down. So we should always put all of our database code inside a try-catch block. And we can throw a SQL exception error if we need. Here are the imports that I told you about. You need these 5 imports in order to use the Jdbc. Explain how a try-catch block works. So we have some Java code. Now it's possible that our Java code could generate a runtime error. We could divide by 0, we could make a mistake and go out of bounds on an array index, whatever. And when that happens, we get some crash and a cryptic error message appears. The only trouble is it may not be cryptic to you, but it's cryptic to someone using the program. The reason why it's not cryptic to you is because you are smart, because you're watching all of these awesome videos. However, the people running your program are not watching these videos. Shame on them. But what would happen is they're going to get this cryptic error message, and they're not going to know what that is. So you wrap your code in a try-catch block. You only have to wrap code that could possibly generate an error. And when that happens, when the program does generate a runtime error, maybe dividing by 0, whatever, instead of crashing and displaying some cryptic error message, your catch code will handle the error, and you could do whatever you want. You can display a message to the user. You could throw one of those exceptions, which will cause the program to crash, and it will display whatever error message you want. You can do or handle the error however you feel appropriate. So let's look at an example of try-catch in NetBeans. So the first thing we're going to do is we're going to declare an array, and let's declare another array. And we're going to declare a variable. I will set it equal to 0. Okay, so now what we're going to do is we're going to loop, and we're going to say I is equal to 0. We'll loop I less than x.length. So we'll loop through the entire x array, I++, typical stuff. And now what we're going to do is we're going to print x divided by y. Now when we run this code, you know what's going to happen. We're going to get a divide by 0 error, because at this location we're doing 3 divided by 0. All of the other ones worked. 1 divided by 1, 2 divided by 2. Oh, we can't do 3 divided by 0. So we get this error message. So how do we handle that? What we're going to do is we're going to wrap this right here inside of a try-catch block. So we're going to say try this code right here. It's possible that right here we could have an error. So we're going to catch the error. What error are we going to catch? Arithmetic exception. We have to have a variable. This variable will hold all of the information about this error message, all this stuff right here. So we can print it if we want, but maybe we don't want to print it. What do we want to do when we get this arithmetic expression? Well, maybe we should just say divide by 0 at index I. So we're going to print a nice, clean message instead of this crash. So let's run the program and see if it works. It did work. We got the divide by 0 at index 2, but we have an array index out of bounds exception, right? Because Y array is not as long as X array. So there is no element 3 or element 4 over here, right? There's only an element 0, 1, and 2. Well, there's 0, 1, 2, 3, and 4 for X. So we need to catch another exception. Which one? Array index out of bounds exception. And what are we going to do here? Well, let's print a nice message here. Index out of bounds, and we'll print the index. Okay, and there you go. Let's try and run this. And here we have our nice clean error messages. This is much better when you're displaying an error message to someone who really doesn't know computer science, or really anybody using your program. You should never display one of those default error messages. You should always have better error messages than this. Now, true, index out of bounds, that's your fault as a developer. You should not have this error happen. So if you don't catch this error, that's acceptable because your program should crash and you should fix it. However, it's possible that you could have a divide by zero error and that's not your fault. You could be asking the person to enter a number. And if they enter the number 0 and you divide by that number, well, there's your error message. So you really should print a nice, clean error message when some things like that happen. You guys have been so good, I threw in a bonus question. If thread number 1 prints the numbers 1 to 100, and thread number 2 prints the letters of the alphabet in alphabetical order, what will be the output if we start thread 1 and then we start thread 2? So for threads, I think it's easier just to jump over to NetBeans and let's look at an example. So in our start method, we're going to actually create a thread and we're going to call it numbers thread. And this is going to be the one that prints the numbers from 1 to 100. So we'll say this is a new thread, open bracket, and then inside here, all threads have to have a method called run. And this is where the method, the thread actually starts running. So what's the thread going to do? We're going to, for int I, 1, I less than or equal to 100. We'll just loop from 1 to 100. And all we're going to do is just print I. Simple enough. Let's create another thread. We're going to copy this. That way we don't have to retype it all. And we're going to call this letters thread. What we're going to do is we're going to create a variable in here, string alphabet. Okay, and then we're going to loop from 0 less than 26, because the alphabet will go from index 0 to 25. And instead of printing the index, we're going to print alphabet.substring I, I plus 1. So we're going to print that letter at that position. So now what happens after we've created these threads? These threads are not running yet. When we're going to start the threads, that's the interview question. What happens if we start numbers thread, which causes the run method to go, and then after we do that, we start the letters thread. Now, most people would think that the numbers thread will go first, printing the numbers from 1 to 100, and then when that's done, the letters thread will run, and we will print the letters A through Z. However, threads don't work that way. Threads are independent pieces of code. They run simultaneously and at the same time. So when we run this, there's no guarantee that this will finish before this starts going. So let's see what happens when we run this. Notice here, let's go up to the top. We start by printing the numbers thread, prints a few numbers, 1 through 9. And then while that's happening, the letters thread actually jumped in and printed a bunch of letters. Actually, it printed all the way to the end. And then the numbers thread continued 10 through 100, as you can see. So where did the letters get inserted? They got inserted between the number 9 and the number 10. Okay, good. Let's run this again. And here we go. As you can see, this time the letters thread actually started running. Before the numbers thread even began, the letters thread finished. And this time the numbers are running in order, 1 through 100, all after the letters. All right, let's run it again. This time, it looks like the numbers all ran first because something got delayed on the letters thread, and then the letters ran. So you notice there's no guarantee. So the answer here is that the numbers from 1 to 100 will print. The letters from A to Z will print, but there's no guarantee on the order in which they will print. The numbers will print in order, the letters will print in order, but there's no guarantee about which one will go first. You could get 2 numbers, then 7 letters, then 5 numbers, then 2 letters. It could alternate. It could go 1A, 2B, 3C, all the way up until the letters are done. And then the rest of the numbers will print. There's no guarantee of anything. Well, I hope you enjoyed this video. If you did, be sure to smush that like button and subscribe to the channel. We've got some really cool stuff coming up. Bye.